The topic is off life. So it is difficult to calculate the time taken by a given sample of n atoms to decay completely. Okay, to calculate the decayed number of atoms, it's very difficult. So, however, we can calculate the time taken by the given sample of atoms to reduce some fraction of the initial amount. So, we can calculate the atoms that is present there when you compare the initial amount what you have before it starts decay. Okay, so like that we can calculate. So we can define the off life as t1 by 2 as the time required for the number of atoms initially present to reduce to one half of the initial amount. So after some time it is reduced into one half of the initial amount. So the off-site life is the important characteristics of every radioactive sample. So this off life, so by the word itself you can know the lifetime is off. Okay, so some radioactive nuclei are known to have a off life as long as 10 to the power 14 years. So some radioactive nuclei will have the lifetime as 10 to the power 14 years, and but some nuclei which has the shorter off life time is 10 to the power minus 14 seconds. So for example, you can take the gamma rays. So we can express the off life in terms of the decay constant. So you can express the off life in terms of the decay constant, that is t, the small, the time that for decaying it takes some time, no? So that time I'm going to represent as t1 by 2 and undecayed nuclei, which means n0 by 2. n0 means the initial amount. In that initial amount the off is reduced, so that is called off life. So n is equal to n0 by 2. So now we will see the equation here. Okay, sorry. So n is equal to n0 e to the power alpha t. So this is what the equation we have seen for the radioactive element decay in the previous topic. So now this n is nothing but undecayed nuclei. Okay, and this is the initial amount nuclei, and this alpha t is decay constant, and this t is the time. Okay, so now how to calculate the off life period? So first, this is t is equal to t1 by 2. So which means if I have number of electrons in one ball shape in a ball shape, I have number of electrons. For example, I'm telling you. So in this will be reduced into off. Okay, that is 10 to the power 14 for some years, and for some metal. Some radioactive nuclei will have 10 to the power minus 14 seconds. Okay, so now the n is equal to n0 by 2. So now just we will take this equation. n0 by 2 is equal to, here in the value I am substituting n0 by 2. In the n I am substituting n0 to n0 by 2. This is off life. No, it is equal to the remaining equation what I have found out for the previous equation. So now when I cancel this n0 and n0, 1 by 2 is equal to e to the power of lambda t1 by 2 will come. So now I'm going to change this equation as taking this 2 to this side and this to this side. So the equation will be like this. Then when it goes up, you will have e lambda t1 by 2 is equal to 2. So now I'm going to take log on both sides. Lambda, it's t1 by 2 is equal to log 2. So why means this e will be cancel when I take log this side. So ln or log is same only. So now taking this lambda to the denominator, so this equation will be become like this. Then t1 by 2 is equal to, for log 2 I have one value 0.6931 divided by lambda. So it's a very important value. You have to memorize this value. So because of log 2 value is 0.6931. So now t is equal to 0, n0 by 2. So sometimes, after sometimes, for the particular time it divides into by 2. Okay, 1 by 2. So after some time, more hours, it divides into 4, then 6. So like that it will go. So n is equal to 1 by 2, n0. So n0 is nothing but initial amount that we have before decay. So now for the activity, so in your book they gave where n can be an integer or a non-integer, since the activity of the radioactive sample also obeys the experimental decay law. So we can also write an equation for activity similar to the equation, this 9.36. Where is 9.36? So like this. Okay, like this you can write for the activity. So here I have written after n off lives, the activity or decay rate of any radioactive sample is R is equal to 1 by n R naught. So R naught is nothing but activity. Okay, so then they have given you the mean lifetime. Okay, mean life. So that is I'm going to represent it with symbol tau. So when the radioactive nucleus decays, the nucleus which disintegrates first has 0 lifetime, and the nucleus which decays last has an infinite lifetime. So from when it starts decay, I don't know the value, initial value will be 0. Sometimes it will go infinity where I cannot find out where it starts, where it ends up with the disintegration. So the actual lifetime for each nucleus varies from 0 to infinity. So it is a meaningful define an average life or mean lifetime theta that the nucleus survives before it decays. So what is mean life? Actually, the mean lifetime of the nucleus is the ratio of a sum or integration of lifetimes of all nuclei. So again I'll read you. The mean lifetime of the nucleus is the ratio of sum or integration, both are same only, of lifetimes of all nuclei to the total number nuclei present initially. So you need to take the initial amount and you have to add all the disintegration of the particular nuclei. So the total number of nuclei decaying in the time interval from t to some changes in time. So d plus del t is equal to the, or del t is equal to lambda n naught e minus lambda t and del t. So R is nothing but the activity. Okay, so then this equation we knows already, and I'm just multiplying it with the time changes. Okay, so it implies that until the time t, this R del t number of nuclei lived. So the lifetime of these R del t nuclei is equal to the T R del t. So this R del t is equal to this. So the del t if tends to 0 means the total lifetime of all nuclei would be the integration of T or dt alone will come, because del t tends to 0 means I can change that to dt. So t is equal to 0 to t will be infinity. So this is the equation they are taking the integration. So this they will not ask for the exam, not for the examination. So for the reference you can see this, and after few integration you will get the value tau is equal to 1 by lambda like this. Okay, note that mean life and decay constant are inversely proportional to each other. So the mean life is decay constant is inversely proportional to the each other. So using mean life, the off life can be rewritten as T1 by 2 is equal to this tau ln 2. So the value. So how I can write? I can write T1 by 2 as a ln 2 tau. So this is equal to ln 2 value we know, and the tau will come. Okay, that's all. So thank you.